This guy is called Steve Fawkes, and he's an expert in energy efficiency. And as you know, this term we have heard a couple of times. Yeah, we believe it's a very important topic, and there's a lot of money to be made, a lot of energy to be saved.
I'm going to show you the big money.
I think we should give him a round of applause and start.
Thank you, yeah. Right, well, it's good to be back at Ecosummit, and sorry to drag you in from the sun. I did something called the Magic of Energy Efficiency last year, so this is the sequel. And I'll start off, this is a very general context-setting presentation. I'm not going to talk about specific details, but we can get into details another time. But quite frankly, if you're not worried about the energy situation that we face, you should be. So, despite all the talk about renewables and all the rest of it, as we know, we're still incredibly dependent on these things. Very large crude carriers carrying huge quantities of oil from oil-producing countries. And as we also know, there's a lot of people in the world who would like to stop that flow of oil for one reason or another. And there's also some people in the world, us included, I guess, who are trying to keep the flow of oil going. And interesting numbers there about the spend of the US on defending the flow of oil through the Gulf. About $279 billion a year, which if you look at Saudi exports is $83 a barrel of Saudi exports. And only 20% of that goes to the US. So if you think forward maybe 10 years when the US becomes independent on energy because of shale gas, are they really going to keep spending that kind of money? Huge, huge investment. Another problem with oil, of course, aging infrastructure and also aging workforce. Doesn't matter where you go, the oil industry is extremely worried about aging workforce. It's a massive oil industry problem at the moment. And going back to Saudi Arabia, a facility somewhere in Saudi Arabia, Saudi produces 10 million barrels a day for export at the moment. And according to Chatham House, the think tank in London, a very good study showed that by 2035, because demand in Saudi Arabia is growing by about 7% a year, domestic demand in Saudi Arabia will equal production. And that's assuming that you're relatively optimistic about what they can produce. So fairly soon, on an energy timescale, we end up with a situation where every drop of oil that Saudi produces would need to be used internally in Saudi. And the same applies to nearly every other oil exporting country. The other big energy security issue to worry about for Europe, of course, although the US is moving towards energy independence, Europe is spending 500 billion euros every year on importing energy. 500 billion euros. I think the last time I checked, the Greek debt was about 380 billion, something like that. So we're talking big, big numbers. And puts us in a very difficult position. And if we're looking forward, as we probably heard earlier today, energy demand is going to grow because we have a growing economy, and by 2030, which again is pretty soon, there will be an additional 3 billion people in the middle class in the world, mostly in Asia, but beginning in Africa and elsewhere, 3 billion people entering the middle class. And it's when you enter the middle class, your energy demand takes a big spike upwards, because you start buying stuff, all the stuff that we generally have. Andreas referred earlier to Africa and 800 million people being without power. If you look globally, it's 1.3 billion people in the world without power. That's an incredible number and a problem and an opportunity, and we need to do something about it. If we look at the other end of the scale on fuel poverty, particularly in the UK, but also in Europe and parts of the US, we have growing fuel poverty because of expensive energy bills. And in the UK, a frighteningly bad statistic, 1.6 million children live in fuel poverty. And if you live in fuel poverty, you have more illness, more deaths, all the rest of it. It's not a good situation. So again, another issue that can be addressed by energy efficiency. This is a picture from 1974. It's not actually me, although I was there, and I was probably in a very similar situation, doing my homework by candlelight in 1974. We had miners' strikes, and we had big power cuts, and industry only had power 3 days a week. And in some countries, many countries, were in that situation. I was in South Africa last week, and there was a Thursday, I think it was the 23rd of May, a couple of weeks ago, where the supply margin on Eskom's system in South Africa was 0.4%. That basically meant if somebody had switched something else on of any scale, the whole system would have fallen over. So supply crunch on electricity in lots of countries. So how efficient are we? Or I always say, how inefficient are we? People don't appreciate this number. This is some work done at Cambridge a few years ago. If you take all of the primary energy that we use, all the fossil fuels, nuclear, renewables, we use 475 exajoules of primary energy. And out of that, we get a whopping 55 units of useful services, so heat, light, motion, sound, and cold. So that means that actually we're only 11% efficient, which I know that some of that we can't address because there are the laws of thermodynamics, but for all our amazing technology, 11% is pretty pathetic in terms of efficiency, which is why I actually have a blog called Only 11%. That's the first of my 2 plugs for this afternoon. So what could be the impact of becoming more efficient? And the IEA and other people, McKinsey, have done all these big studies, and it doesn't matter what study you look at, the potential is huge. And I'm not going to go through these numbers, because as I said to Jan earlier, I'm trying to eliminate bullet points in presentations, but I think the really interesting one there is in the IEA's efficient world scenario, global output by 2035 would be boosted by $18 trillion, which is the equivalent of the US GDP, Canadian GDP, Mexican GDP, and Chilean GDP all added together. So it's a massive potential, absolutely massive potential, both for economic growth, saving fuel, reducing cost, and of course, reducing greenhouse gas emissions. In this IEA scenario, greenhouse gas emissions go up and then start coming down as efficiency kicks in. So absolutely massive potential. The other thing about energy efficiency that's worth remembering, of course, we've seen some numbers, I'm sure, and all talked about renewables. These are levelized cost of energy for different renewable sources, and they come from Fraunhofer up the road, and who we heard from earlier. And you can see that energy efficiency is the cheapest by a long way. So energy efficiency is actually the cheapest form of energy that we have, absolutely by a long way. It's also very quick to deploy, and it's very clean, the cleanest, in fact. Of course, economic situation being what it is around the world, job creation is very important. Everybody wants more jobs, and lots of work, lots of studies in different places, this is actually an American study, show that energy efficiency creates more jobs per $1 million spend than either energy generation by a long way, so 21 jobs per million as opposed to 10, and more jobs than the economy as a whole. So if we switch resources from supply into efficiency, we will inherently create more jobs. So lots of people say, okay, there's all this huge potential for energy efficiency, but why isn't it happening? It's the wrong question. You need to look at it in a different way. Energy efficiency is happening in a massive way. We just don't see it. It's sort of invisible most of the time. And this is the one sort of chart that I have. This is, again, the US economy, but the same applies to all developed economies. The blue line at the bottom is the energy demand in 1970, and it's somewhere around 70 quads, something like that. 68 quads using the quadrillion BTU, which I know is a terrible unit, but it's convenient when you're talking about the US economy. And the second line up, the kind of orangey brown, says the actual energy supply, so that's the supply of energy as it is, which today is about 98 quads. And the top two lines, don't worry the fact there's two, one is with exports and one is without exports, but the top two lines show the energy we would be using if we still had the efficiency that the US economy had in 1970. So, energy demand would be far, far greater in the US and everywhere else if we had not had energy efficiency happening. And the really interesting part of that is on the right-hand side of the curve, of the graph. And it shows the different types of energy making up the existing US supply. So we have oil at the bottom, coal, gas, renewables, nuclear, and then other. And then you look at what energy efficiency has done, and it's bigger than the rest put together. So over the last 40 years in the US economy and in the European economy, energy efficiency has actually supplied more energy services than all other types of energy put together. And that's one of the aspects of the magic of energy efficiency. And we did that without even trying. Apart from a period of about 1975 to 1985, we didn't really care about energy efficiency until a few years ago. So if we did that without trying, just imagine what we could do if we really put our minds to it. Okay, so just briefly, I'm going to run through some opportunities for new products and business models. Again, not getting into detail, this is a very kind of contextual presentation. Housing, wherever you are, housing makes up a big proportion of energy load. Probably most people have seen this, the Nest thermostat. It's one of many intelligent thermostats that have been launched in the last few years. It detects the conditions in the house, it can talk over the internet, all those things, and it really does save energy in homes. And last time I spoke to Nest, they're talking about coming to Europe this year, maybe next year. And the beauty of this thermostat, of course, Nest, why it became so popular was it looks cool. Never before in the history of thermostats had anybody designed a thermostat that was cool and people wanted. And it's sold out, which just shows what you can do with good design. It was actually designed by a former Apple designer. Okay, commercial office buildings and commercial buildings generally, absolutely massive potential for energy efficiency. Big study by Deutsche Bank and Rockefeller showed there was a $279 billion investment opportunity. And if that was all exploited, 3.3 million jobs, 600 million tons of greenhouse gas emissions saved. And that's all profitable investment opportunity. I think lots of people in the last few years have seen the Empire State Building case. The Empire State Building is a really interesting example. It was being renovated for other reasons, not for energy efficiency. It was being renovated because basically it was a pretty poor building. And if it had been any other building than the Empire State Building, it probably would have been knocked down. But by designing and taking a holistic approach to designing the retrofit, they were able to spend a small amount of extra capital but get a 3-year payback on that capital and save 38%. So if you can save 38% in a very difficult building like the Empire State Building and have a 3-year return on capital, just think what you can do in easier buildings. Building materials, huge opportunities in building materials. This is electrochromic glass from View Glass. View is one of many companies who've developed electrochromic glass. And this is glass that changes its visual and thermal characteristics at will and controlled by building systems. And 20% reduction in energy for the HVAC system and 23% reduction in peak load compared to standard E-glass. So again, huge potential. View Glass. Lighting. Everybody knows there's a lighting revolution going on, LED. Just imagine the benefits if you managed to put LED lighting into all of those lights in London. Well, McKinsey did a study a few years ago, and they looked at the penetration of LEDs into different markets, and they compared the savings that will occur by 2020 to the number of nuclear reactors. Very interesting results. If the US, by 2020, the deployment of LEDs will be saving the equivalent of 19 reactors. Germany 3, Japan 7, China 17, and India 9. So the impact of LED lighting on the supply and the need to build new supply capacity is absolutely massive. There was mention earlier about big data, and I'll come back to big data in a minute, but the adding of intelligence to dumb systems and buildings is really powerful. This is an example in Charlotte, in North Carolina, where they've linked up all the buildings in the downtown area, and they record and display energy consumption in real time. And that project is on track to save 20% in a whole group of buildings in the downtown area. Big data. I just read a book on big data. It's very interesting. This is New York. In New York and Chicago, they've made all the data on energy consumption of buildings public. Obviously, there are safeguards in place about making it anonymous, but you can look on website portals and see the data on consumption. And in Chicago recently, they had a hackathon, which is a great new title I'd not come across, where they basically invited anybody in to look at this data and analyze it in new ways with big data tools and come up with new ways of saving energy and making the city more sustainable. So huge potential yet for big data. Manufacturing, some numbers from the Rocky Mountain Institute. Again, huge potential, and that's both in buildings, process, but also fundamentally in the way things are made. There was mention earlier about 3D printing. 3D printing will be a huge energy efficiency gain. Absolutely certain about that. And it's not only 3D printing, it's things like near shape casting of titanium or other metals. All of those things will make a huge impact on energy consumption. Vehicles. That's actually the aluminium body of the Jaguar XJ, for those that are into cars. Great car. Of course, it has an aluminium body primarily to save weight. And Henry Ford made a very good statement in 1924. He's famous for many statements, but I hadn't seen this one before. Excess weight kills any self-propelled vehicle, unless it's a steamroller. And MIT did a study that showed 10% weight reduction is about a 7% gain in fuel efficiency. And aluminium, just aluminium, forgetting composites or other materials, has the potential to save about 40% of the weight of vehicles. So again, huge potential. And that's an impact of materials on energy efficiency. Transport, I said about adding intelligence to dumb systems, transport, networking, vehicles, networking traffic, roads, all of those things are going to happen and have huge potential. Shipping, not an area that you often think about energy efficiency, but shipping actually emits more carbon dioxide than aviation. And again, Stena, in this case, a new design of tanker, 10 or 15% savings. And that's only the beginning. They've got other plans on track. 787 had a lot of publicity recently, not the best kind of publicity Boeing had, but the main rationale for the design of 787 was fuel efficiency, and there is a measured saving in operation, not marketing hype, measured saving of 21% compared to a 767. And that was on early aircraft, which are always overweight. They're about 2 tons overweight, those aircraft, so by the time they get the extra weight out, there'll be even more. Energy industry, gas flaring, huge potential, and other potential in the power generation industry. So energy efficiency opportunities everywhere. There's lots of money on the floor waiting to be picked up. This is some big money. I said I'd show big money earlier, £50 note, maybe not as big as it used to be. It actually features Bolton and Watt. And Watt invented a more efficient steam engine, and Bolton commercialized it, and that's how they made their fortune. So energy efficiency, old idea. I'm not going to talk my own book, but actually anybody who's more interested in getting more details, I do have a new book coming out later in the year, and there is a big discount for early orders. So this covers the whole topic of energy efficiency from potential, technology, finance, management, and just the whole field. So I definitely recommend it. So with that, I'm going to be quiet because I know I've exceeded my time, which I try not to do. But that is really the magic of energy efficiency. It's the biggest, cheapest energy resource that we have, and it's achieved a lot, but there's an awful lot more to go for. Thank you.
consider yourself booked as part of the agenda in London.
I will do that. I'll put it in my diary.
Yeah, no, very, very excellent talk. Thank you so much. And I think people can learn about using strong images from you. Do you have a question for Steve?
Just a short question about, you mentioned big data and hackathon. It makes me thinking about the Clean Web initiative in the US. I don't know if, and what's your perspective of what can be achieved thanks to this kind of initiative on the whole chain, not only prototyping during a hackathon, but the whole chain from liberate the data and makes this a sustainable business that grows?
I think there's very big opportunities, and then Chicago and New York are starting to show that, but they've only just really started in the last year or so. But they've already identified projects and savings, not only in energy, but water, operations and maintenance, all kinds of areas. So that whole area, if you can overcome the privacy and the security of data issues, that whole big data approach has massive potential. And I think just to finish, I think some of the US cities have really actually got it now. Here in Europe, we do tend to demonize them sometimes, but Chicago's definitely got it. New York's got it.
The role model, Chicago?
Yeah, Chicago's a good model.
How they handle big data?
Well, big data, but also sustainability generally.
Yeah. Okay. Great. Thank you very much to Steve.